Right, good afternoon, everybody. Today, what we're going to do is look a bit at the pediatric ECG, just for 10 minutes or so. This is going to be as part of the whole pediatric cardiology block, and particularly because some people were having concerns about the ability to interpret the pediatric ECG. So we just thought after the pre-reading that we were sent out that we'll spend a few minutes. A lot of us, certainly when I was a junior, and somebody gave me a pediatric ECG, I probably look a bit like this. And I see this expression a lot of the time when some of my juniors come up and ask about, an ECG that they've done. It's confusing and it's concerning because it looks strange compared to the adult ones that we see all the time. And the thing is, a lot of the ECGs, they say up to 20% of pediatric ECGs that we do will be abnormal. But the secret to being happy with it is like we talked about, the more you practice, the more you look at these things, the more comfortable you get at it. So by the end of today, hopefully what we should be able to do, given that you've read the stuff that was sent out on my e-learning, so you should be able to evaluate a child's ECG in a systematic fashion, just as you would an adult, but with some caveats. And you'd also be able to identify what's a normal variant in children's ECGs, so that you don't get alarmed by seeing these things that look really abnormal if you saw them in an adult or older child. So the first thing we're going to do, we are broken up into groups today. So 1, 2, 3. So there's 4 small groups, okay? So the first thing we're going to do is just review some of the things that, you're given an ECG. What's your system? What's the way that we move along and look at it? Sorry? Yes. So rate. So the first thing you do is look at the rate, and you have to check the paper speed, obviously, yes. And how do you measure the rate? Correct. So 300 divided by the RR, or there's other methods. Yeah. Rhythm is the next thing, and in children in particular, you can get sinus arrhythmias. So the heart rate speeds up and slows down, but the PR interval remains the same and the P wave morphology remains the same. So you know that it's a sinus arrhythmia. What's next? Correct, the axis. Now, in utero, because of the way the heart pumps blood, the right ventricle is predominant. And in neonates, the right ventricle is still the main workhorse of the heart. Therefore, the axis is rightward. This gradually, when the child is born, the axis gradually moves leftward as the left ventricle becomes more dominant. But this takes place over a few months or years, actually. So you'll gradually start off with a right dominant axis, moving gradually leftward to the normal axis. And we look at that later on in terms of the normal ranges. What else? Right, so the P wave. So you look at the P waves, and for normal axis, the P should be upright. In which leads? Right, so 2, 1, 2, and in AVF. And it should be negative in AVR. Anything outside of that would suggest that the P wave origin is abnormal. QRS. So the QRS, remember the heart muscle is small, the heart is small, so therefore the QRS, which is the ventricular repolarization, would be smaller, would be of a narrower and of a lower voltage although to some degree that is compensated by the thin chest wall. So remember that the QRS is not the same as in an adult, so you'll get very narrow QRS. You'll get an RSR pattern in V1, which is normal, which looks like an incomplete right bundle, but it's normal. You'll get prominent Rs because of the dominant R right ventricular wall, and it's only as the heart becomes more mature you'll lose this dominance on the right precordial lead, so V1, V2, V3, and it moves gradually to V5, V6. After QRS, what's the next thing? Okay, yeah, so T and QT. So the QT is important to measure because as the heart rate is increased, because in children the heart rate gradually reduces as they get older, so does the QT interval change. So it's not uncommon for neonates to have a prolonged QT up to 0.49 milliseconds. So that has to be borne in mind. And we know how to measure it. Yeah, Bazet's formula. Good. Okay. And next, the T wave. Right. So as you can see in neonatal, in newborn, first few days as a newborn, what happens to the T wave? It's upright. Yeah, that's correct. So an upright T wave is because why? Good. So the upright T wave is because the what we talked about in the fetal circulation. So the upright T wave is due to the fact that the repolarization, the extreme right axis, the repolarization is coming from the right side. As within the first few days, as the neonatal circulation takes over, T waves become inverted, and this remains like that up until about 8 to 10 years of age, and then it goes to the adult pattern. So in your groups, we'll look at some ECGs now just to practice that, right? So go through it in the same format, write down the answers, and we'll take 30 seconds to do that. Good. So this shows sinus rhythm. The rate is about 120, correct? Normal P wave axis, normal QRS. The anterior T wave inversion that we see here, is what we call the juvenile T wave pattern, and that's something that you would see commonly up till about the age of 10. Sometimes it could go into adolescence, into young adult, and we call it persistent juvenile T inversion. So it could be alarming because you would be accustomed to seeing this and thinking, oh, ischemia, but it's not. Okay, notice the R waves, very dominant R waves in the right chest leads, and gets bigger up to V4 and then reduces in size. So very good. Next one. Racing heart, 30 seconds. Okay, so the same thing, again, is RSR, incomplete right bundle pattern. That's a normal variant. You have the anti-wave inversion in the precordial, the right precordial leads. You have normal R wave progression. Now look at the QRS though. You see this little bit of slurring there? So it's not a nice sharp upstroke. Yeah, that's from pre-excitation. That's WPW. 2-year-old girl with a murmur. So juvenile T inversion. But look at the R waves. Very, very big R waves in the left precordial leads. And what would give that? Yeah, so left ventricular hypertrophy. So in the presence of a murmur, is thinking, well, is there something that's causing the left heart to increase in size, to hypertrophy? So it's LVH with an VSD. Okay, so that shows you, that demonstrates why the context is important. This is the normal ranges, just to clarify. or just to emphasize, heart rate reduces, your QRS increases gradually, the axis becomes normal, so leftward from rightward, and you don't need to memorize this. These tables are freely available and they're in apps. We'll post it up as well. So the last thing, I just want to ask a couple of favors. So give some feedback first of all. So the sticky notes that you all have, we've done this before. So if you could just write 1 or 2 things that you would want me to start to do for these lessons, to stop doing, because I have bad habits like everybody else, or to change, so do things that would make it easier for you to pick up stuff. The last thing I want you to do before we go to is to take a minute to write down one of the more important things you've learned today, and also what areas weren't very clear or wasn't answered well. And then what we can do is I'll look at this and then maybe take 5 minutes at the next ECG session to just run through those things, or I'll send you some further reading or a screencast on my learning. So in summary, use a systematic approach, same as you would do in adults. Make sure and interpret it in context when you request an ECG, because often the clue would be there. Remember that the ECG changes as a child grows, so you get some variants which are expected but can look really abnormal. And don't worry to learn all the normal ranges. Some of them you'll pick up as you practice, but you could be referenced as you go along. Here are some exercises that I would want you all to look at just to practice, and I'll put these up as well to link in. Thank you very much. Don't forget to do the feedback.